far beyond the reaches of our everyday perception, across unimaginable distances, lie some of the most mysterious objects in the universe. Black holes, cosmic giants that defy the very laws of physics we've come to understand. They are regions of space where gravity is so strong that not even light can escape, pulling everything in their vicinity into an abyss of infinite density. For decades, these dark enigmas have captivated the imagination of scientists and dreamers alike. Yet, despite their immense power, black holes might hold the answer to a question that haunts us. What is dark energy? Could the deepest, darkest parts of the cosmos be the key to understanding the mysterious force that drives the accelerated expansion of the universe? A black hole is born from the collapse of a massive star. As the star's nuclear fuel runs out, it succumbs to its own gravity, collapsing into a singularity, an infinitely small and dense point where the laws of physics break down. Surrounding this point is the event horizon, the boundary beyond which nothing can escape. Everything that ventures too close, whether matter, light, or even time itself, gets trapped in this cosmic prison. But beyond their fearsome reputation as devourers of everything in their path, black holes are more than just cosmic vacuum cleaners. They are portals to a realm where space and time are stretched, twisted, and manipulated in ways that we can hardly comprehend. And it is here, in the extremes of black holes, that we find ourselves asking, could they be the key to unlocking the mystery of dark energy? Dark energy. It's a force so mysterious that, despite making up almost 70% of the universe's energy content, we still know almost nothing about it. Unlike the matter and gravity we are familiar with, dark energy doesn't pull things together. Instead, it seems to be pushing everything apart, accelerating the expansion of the universe at an ever-increasing rate. Its effects are both subtle and immense, stretching across the very fabric of space-time itself. But why is it so hard to understand? Why, after centuries of study, does this force remain hidden from us like a phantom lurking just beyond our grasp? The answer may lie in the most extreme environments of space, the black holes. Could these massive objects, with their intense gravitational pull and warped space-time, provide a clue to the nature of dark energy? One thing we know for certain is that gravity plays a central role in the cosmic dance between matter, energy, and space-time. When a massive object like a black hole bends space-time, it warps the very structure of the universe. And where gravity is strongest, at the event horizon of a black hole, the effects are most pronounced. Here, space and time themselves break down, defying everything we know about the rules of physics. But this warping of space-time might not be just a local phenomenon. It could be linked to the cosmological constant, the theoretical force that underpins dark energy. Perhaps black holes are not simply regions of destruction. They may also be intricately tied to the energy that is causing the universe to expand ever faster. Could these singularities be connected to the vast energy fields that stretch across the cosmos? Some theories suggest that black holes might act as gateways to other dimensions or regions of the universe. Could a black hole be more than just a one-way passage to oblivion? Could it, in fact, be a doorway to other realms, where the very forces of dark energy are created, stored, or amplified? These are questions that challenge the boundaries of our knowledge, pushing us toward new understandings of the universe's deepest secrets. Imagine, for a moment, that inside the heart of a black hole, a fundamental connection exists between space-time itself and the mysterious force that accelerates the expansion of the cosmos. The quantum fluctuations at the core of these black holes might be telling us something profound, something we can only begin to understand if we have the tools to peer into this cosmic abyss. In our quest to understand dark energy, we turn to the most advanced tools at our disposal: space telescopes and detectors that peer into the very heart of black holes. Instruments like the James Webb Space Telescope and the Event Horizon Telescope are providing us with the clearest images yet of black holes and their surrounding accretion disks. With these observations, we are beginning to unravel the enigmatic behavior of these gravitational monsters and their possible link to the mysterious forces driving the expansion of the universe. But despite these technological advances, the journey to understanding remains perilous. We are attempting to comprehend forces so alien, so extreme, that the very fabric of space-time is stretched to its breaking point. And as we venture deeper into this unknown territory, we encounter paradoxes, contradictions, and more questions than answers. Perhaps the most tantalizing aspect of our search lies in Hawking radiation, a theory proposed by Stephen Hawking, which suggests that black holes are not entirely black. Instead, they slowly radiate energy as quantum particles are generated near the event horizon. This radiation, though faint, could hold the key to unlocking the deepest mysteries of both black holes and dark energy. The problem is, this radiation is incredibly difficult to detect. The energy emitted by a black hole is so subtle, so minuscule compared to the vastness of the universe, that it would take incredible precision and sensitivity to measure it. But what if one day we can detect it with the right instruments? What if, within this radiation, we find not just a glimpse of black hole dynamics, but the fingerprints of dark energy itself? Another fascinating possibility is that supermassive black holes, those gargantuan objects at the centers of most galaxies, might influence the expansion of space itself. Their gravitational pull shapes galaxies, bending and twisting the fabric of space-time. But could they also be amplifying the effects of dark energy? As space expands, the presence of these black holes could help reveal the true nature of the energy that drives it. For years, scientists have speculated that these cosmic behemoths could provide the answer to how the universe's expansion is accelerating and whether dark energy plays a role in this process. As galaxies orbit and interact with supermassive black holes, the fabric of space itself may be stretched in ways we cannot yet fully comprehend. Black holes are not just destroyers. They are creators, too. Their jets, streams of energy and matter, can shape the very structure of space-time itself, influencing the formation of stars and galaxies. It's possible that these jets could play a role in spreading dark energy across the universe, pushing the edges of space outward, fueling the cosmos' accelerated expansion. Could the power of a black hole's jets, its energy and matter, be responsible for the forces we associate with dark energy? This is a question that remains unanswered, but with every new discovery, we inch closer to understanding the true role these cosmic monsters play in the grand scheme of the universe. As we stand on the precipice of discovery, one thing is clear: black holes are not merely cosmic curiosities. They are crucial pieces of the puzzle, a puzzle that might one day reveal the true nature of dark energy and its role in the accelerating expansion of the universe. To understand dark energy, we must first understand black holes. To do that, we must venture into the heart of these dark giants, where time, space, and reality itself break down. And as we peer deeper into the unknown, we begin to glimpse a truth that is far larger than ourselves. The universe is not a passive place. It is a living, breathing entity, expanding and evolving, shaped by forces we are just beginning to understand. And black holes, these cosmic monsters, might just hold the key to unlocking the greatest mystery of all, the force that is driving the universe itself into an ever-accelerating future. The search for dark energy is not just about science. It's about a deep, unyielding quest for understanding the nature of the cosmos, the forces that govern it, and our place within it. As we continue our exploration, we find ourselves at the very frontier of knowledge. Every discovery we make brings more questions to the surface, and with each answer, the universe grows even more mysterious. We are on the edge of a new era of discovery, one that could rewrite everything we know about the universe. The journey to uncover the true nature of dark energy and its connection to black holes is only just beginning. And as we venture further into the depths of space, we may one day find that the answer to the greatest mystery of the cosmos lies within the heart of the darkest, most mysterious regions of the universe.